have you ever considered if a statement could be both true and false at the exact same time? Now, in our everyday lives, that sounds, completely impossible. But in the world of logic, there is this fascinating, really powerful system that's designed to do just that. So let's dive into the strange and frankly amazing world of paraconsistent logic.
So here's our game plan. We're going to start with the big problem at the heart of what we call classical logic. Then we'll meet the radical solution that actually embraces contradiction. We'll check out a few ways it works, see where it fits in the bigger picture, and then wrap up with why this super abstract idea really matters in our messy, real world.
All right, first things first. To understand the new thing, we've got to understand the old thing we're breaking. So let's take a look at how logic has worked for centuries and uncover its kind of surprising weakness.
Seriously, think about that for a second. Your gut instinct, and pretty much centuries of philosophy, would just scream, no, of course not, right? A light is either on or it's off. A number is either even or odd. It seems totally fundamental. Well, that black and white framework, that's what we call classical logic. And for ages, it's been the absolute bedrock of mathematics, computer science, philosophy, you name it. It's clean, it's reliable, and it works beautifully. Well, most of the time.
But here's the catch. It has a critical vulnerability, a real Achilles heel. It's known as the principle of explosion. And what it means is that classical logic is shockingly fragile when it comes up against just one tiny contradiction.
And this is the part you really have to get. If you let a classical logic system accept that A and not A are both true, the whole thing just shatters. All of a sudden, you can logically prove that the sky is purple, that 2 + 2 = 5, that dogs are secretly cats. Literally, everything becomes provable. And when everything is true, the whole system is useless. It just becomes trivial.
So that fragility, that's a huge problem when you're trying to deal with inconsistent information. So what's the solution? Well, it's a new kind of logic that doesn't run from contradiction. Instead, it embraces it.
And this is paraconsistent logic. Its whole reason for being is to be contradiction tolerant. It is designed from the ground up to allow for inconsistencies inside a system without that catastrophic explosion we just talked about. It accepts that, hey, sometimes information just conflicts.
Let's think of it this way. Classical logic sees a contradiction and it just explodes. Paraconsistent logic, on the other hand, it builds a firewall. It basically says, okay, we've got a contradiction over here in this one little spot. We're going to acknowledge it, we're going to contain it, and then we're going to keep reasoning logically about everything else.
This makes it an incredibly robust and powerful tool. I mean, just think about the real world, right? It is full of conflicting data, different opinions, incomplete information. A logic that can actually handle that without just completely breaking down, that's a game changer.
So how do logicians actually build these firewalls around contradictions? I mean, how does it actually work? Let's look at a few of the key methods that they've come up with.
Now, there isn't just one single way to do this. It's more like a toolkit with a bunch of different instruments for the same job. For instance, some of the earliest systems, like Jaschkowski's discursive logic, work by imagining a debate. You know, in a real discussion, one person can say the market's going to go up and another can say the market's going to go down. Both of those statements exist in the conversation, but the whole discussion doesn't turn to nonsense. This logic just formalizes that idea. Another approach is to circumscribe the problem, which uses these really complex formulas to literally draw a boundary around the contradiction. Basically saying, okay, this part here is inconsistent, but we can still reason logically about everything outside this fence. All these different tools have the same goal: contain the contradiction.
And a lot of this field really goes back to the Polish logician Stanisław Jaschkowski. His work in the middle of the 20th century laid all the groundwork. He created a formal calculus specifically for these kinds of inconsistent systems, which, back then, was a totally revolutionary idea.
Okay, let's zoom out a bit. Paraconsistent logic isn't just some clever parlor trick. It is part of a much bigger philosophical shift in how we even think about what logic is. It belongs to this family of logics that we call non-classical. And they're called that for a reason. It's because they challenge some of the oldest, most fundamental assumptions about how truth and reasoning are supposed to work. And one of the biggest assumptions they challenge is something called Frege's principle. The classical view says that a sentence like "the sky is blue" is basically just a fancy name for the concept true. So in that view, the sentences "the sky is blue" and "grass is green" can be swapped out for each other in an argument, because who cares what they say? All that matters is that they both point to the same thing: true.
And this is the huge idea that non-Fregean logics just completely reject. They argue that the meaning of a sentence, its semantic reference, is just as important as whether it's true or false. Sure, the Earth is round and 2 + 2 = 4 are both true, but they mean completely different things. And that difference in meaning, it matters.
And when you move beyond just true and false, you unlock this whole new level of analysis. Suddenly, you have the power to reason not just about truth, but about meaning. And this creates a kind of unified framework where all these different logical systems, classical, paraconsistent, can be compared side by side. And that lets us ask much deeper questions about the nature of logic itself.
Okay, I know. This all sounds very academic, very philosophical. But a logic that can tolerate contradiction is not just some theoretical curiosity. It has some really profound, practical applications in our modern world.
Just think about it for a second. Where do you see conflicting information every single day? The sources are everywhere. News reports, scientific data, just simple human error.
And this is where it gets really real. Imagine a massive corporate database with millions of entries. It's practically guaranteed to have some conflicting information in there. Well, paraconsistent logic can help query it without having the whole thing crash. Or think about an AI in a self-driving car that's getting contradictory data from 2 different sensors. Or a legal system trying to make sense of 2 witnesses who say the exact opposite thing. These are all situations where we have to reason logically, even when we're staring a contradiction right in the face.
So, here's the bottom line. Paraconsistent logic is a toolkit for clear thinking in a messy world. It looks at reality, acknowledges that information can be imperfect, and it gives us a formal, rigorous way to handle that imperfection without just giving up on logic entirely. And that leaves us with one last thought. So often we try to force the world into these simple black and white boxes. But if our most rigorous tool for thinking, logic itself, can learn to embrace contradiction, what does that say about our own deeply held beliefs? What assumptions in our own thinking might be ready for a similar kind of challenge?